Hello everyone. Last time we have completed the exact and non-exact and methods to find PI. So today we are going to start with linear differential equation. Now, when the equation is said to be linear, if it is of the form dy by dx plus px into y is equal to qx, then it is called linear. So if you have this type of equation, then the equation is called a linear differential equation. We are going to rewrite it in the form of py minus q plus dy by dx is equal to 0. So that will give you py minus q into dx plus dy is equal to 0. So applying the case of integrating factor, m is equal to py minus q, n is equal to 1, del m by del y is p, and del n by del x is 0. So 1 upon n del m by del y minus del n by del x is equal to 1 upon 1 into p minus 1, 0. That will be a p. But p is only function of x. And therefore integrating factor is if is equal to e raised to integration p dx. Now multiplying equation 1 by if, that will give e raised to integration p dx into dy by dx plus y into e raised to integration p dx into px is equal to q into e raised to integration p dx. Now see, this is basically the derivative of y into e raised to p dx. First derivative of y, e raised to as it is, that means it is dy by dx into e raised to integration p dx plus y as it is, and derivative of e raised to is e raised to, and that derivative of integration, that will be a px. So this is a d by dx of y into e raised to integration p dx. So now you have to integrate both sides. So integrating both sides, that will give you y into e raised to integration p dx is equal to integration q into e raised to integration p dx plus c. So y into if is equal to integration q into if dx plus c. Okay. So this is the general solution of equation. Now suppose you have given the equation, solve dy by dx plus 4x upon x square plus 1y is equal to 1 upon x square plus 1 whole cube. So here your p is 4x upon x square plus 1, q is 1 upon x square plus 1 the whole cube. So if is equal to e raised to integration p dx is equal to e raised to integration 4x upon x square plus 1 dx, and that will be e raised to 2 into log of x square plus 1. So simplifying this one, so this will be going in the power, 2 will be in the power of x square plus 1, and e raised to log will be cancelled out, and we have x square plus 1 the whole square. So the general solution is given by y into if is equal to integration q into if dx plus c. So y into x square plus 1 whole square is equal to integration 1 upon x square plus 1 whole cube into x square plus 1 whole square dx plus c. So x square plus 1 cancel out 2 times, and that will give integration of 1 upon x square plus 1. But integration of 1 upon x square plus 1 will be tan inverse x. So that will give you y into x square plus 1 whole square plus tan inverse x is equal to c. Or you can write down that y into x square plus 1 whole square minus tan inverse x is equal to c. Same manner. So same manner we are going on to second example. Solve dy by dx plus 1 upon 3 into y is equal to 1 upon 3 into 1 minus 2x into x raised to 4. So here p is equal to 1 by 3 and q is equal to 1 by 3 into 1 minus 2x into x raised to 4. Okay. So what the if is equal to e raised to integration p dx, that will be e raised to 1 by 3 dx, that will be e raised to x by 3. and the general solution is y into if is equal to integration q into if dx plus c. So y into e raised to x by 3 is equal to integration 1 upon 3 into 1 minus 2x into x raised to 4 e raised to x by 3 dx. Now see, you cannot directly integrate this. So multiplying this x raised to 4 inside, 1 by 3 common out from the integration, that will give you 1 upon 3 e raised to 1 upon 3 integration x raised to 4 minus 2x raised to 5 into e raised to x by 3 dx. Applying u into v. So u as it is integration of v. So e raised to x by 3 as an integration e raised to x by 3 upon 3. Minus derivative of this term, that is 4x cubed minus 10x raised to 4. And again second integration, that will be e raised to x by 3 upon 9. Or x by 3 into 9. Again derivative of this term, that will be 12x square minus 40x cubed. Again integration, that will be e raised to x by 3 into 27. Again differentiation of this one, that will be 24 minus 120x square. Again the integration of this term, that will be e raised to x by 3 into 81. Again differentiation of this one, that is 24 minus 240x into e raised to x by 3 2 into 243. And again differentiation of this one, that is minus 240 into e raised to x by 3 into 720. Now again derivative of this term will be 0. So here we are going to stop. Simplifying this one. So e raised to x by 3 common out from all and dividing by 3 inside. That will give you the simplified term. And after simplifying all this, we have the final answer e raised to x by 3. Sorry, y into e raised to x by 3 is equal to e raised to x by 3 into minus 2x raised to 5 plus 31x raised to 4 minus 372x cubed plus 3348x square minus 20,088x plus 60,264 plus c. Now another example, 1 plus y square into dx by dy is equal to tan inverse y minus x. Now instead of the dy by dx, this equation is in the form of dx by dy. So we are going to write this in the form of dx by dy plus 1 upon 1 plus y square x is equal to tan inverse y upon 1 plus y square. So here p is equal to 1 upon 1 plus y square and q is equal to tan inverse y upon 1 plus y square. So what we have to do is if is equal to e raised to integration p dy, that is e raised to integration 1 upon 1 plus y square dy, that is e raised to tan inverse y. And the general solution is, instead of y into, now it will be a general solution will be in the form of x into if is equal to integration q into if dy plus c. So x into e raised to tan inverse y is equal to integration tan inverse y upon 1 plus y square into e raised to tan inverse y dy plus c. So put tan inverse y is equal to v. That will give 1 upon 1 plus y square dy is equal to dv. So this integration is in the form of v e raised to v dv. Now applying u into v. V as it is derivative of e raised to, or integration of e raised to v is e raised to v. Minus derivative of v will be 1. Again integration of e raised to v, that is e raised to v. And e raised to v will be common out. That will give e raised to v into v minus 1 plus c. Putting the value of v, that will give e raised to tan inverse y is equal to e raised to tan inverse y into tan inverse y minus 1 plus c. Now we are going on to the Bernoulli. Bernoulli is basically the equation reducible to linear. There are two cases. First one is equation is of the form dy by dx plus dx into y is equal to qx into y raised to n. This y raised to n is an extra term. So dividing by y raised to n, that will give you y raised to minus n dy by dx plus px into y raised to 1 minus n is equal to qx. Now what we are going to do is, we are going to assume that y raised to 1 minus n is equal to u. Whatever the term with px, that will be u. So y raised to 1 minus n is u. So differentiating with respect to x, that will give 1 minus n y raised to minus n dy by dx is equal to du by dx. And that will give you y raised to minus n dy by dx is equal to 1 upon 1 minus n du by dx. So putting these values in equation 2, that will give you 1 upon 1 minus n du by dx plus px into u is equal to qx. And therefore what we have is du by dx in plus 1 minus n into px into u is equal to 1 minus n into qx. Now this is the form of linear equation. We are going to consider this 1 minus n into p as a one function and 1 minus n into q as another function. So this is a function of x, this is a function of x. So it is a form of linear. Same manner, instead of power of y, if you have the function of y, then in that case the equation is of the form f dash y dy by dx plus px into fy is equal to qx. Here you have to assume fy is equal to u, and in that case f dash y dy by dx is equal to du by dx. So if you are going to put this value here, then this term will be du by dx and this term will be u. So your equation is of the form du by dx plus px into u is equal to qx, which is again a linear. So in each case you are reducing it to the linear form and then finding the solution of linear differential equation. So first we are starting with the example. Solve the differential equation x dy by dx plus y is equal to x cube y raised to 6. So here the power of y is extra. So dividing with, first we are dividing it with x. So this is dy by dx plus 1 upon xy is equal to x square into y raised to 6. Now dividing with y raised to 6, that will be y raised to minus 6 dy by dx plus 1 upon x y raised to minus 5 is equal to x square. This is your equation number 1. Now what you have to do is, you have to assume y raised to minus 5 is equal to u. You have to assume for this term, whatever the term with px. So y raised to minus 5 is equal to u. That will give minus 5 y raised to minus 6 dy by dx is equal to du by dx. So you have y raised to minus 6 dy by dx is equal to minus 1 upon 5 du by dx. Now putting these values in equation 1, that will give minus 1 upon 5 du by dx plus 1 upon x u is equal to x square. And that will give du by dx minus 5 upon u is equal to minus 5x square, multiplying this equation by minus 5. So your px will be minus 5 upon x, qx will be minus 5x square. So if will be e raised to integration p dx, that is e raised to integration minus 5 upon x dx, that is e raised to minus 5 log x, and that will be x raised to minus 5 or 1 upon x raised to 5. And the general solution is u into if, because see, now your variables are u and x. So u into if is equal to integration q into if dx plus c. So u into x raised to minus 5 is equal to integration minus 5x square into x raised to minus 5 dx. So u is y raised to minus 5. Here integration of x raised to minus 3, that is x raised to minus 2 upon minus 2. So you will have 1 upon x raised to 5 y raised to 5 is equal to 5 upon 2x square plus. This is your final answer. Now the second case, instead of power of y, if you have a function, then dy by dx plus x sine 2y is equal to x cube into cos square y. So here the function of y is extra. So dividing by cos square, that will give us x square dy by dx plus x sine 2y upon cos square y. Now sine 2y is 2 sine y cos y. Simplifying this term, cos cancel out, sine upon cos will be 10. So you have x square y dy by dx plus 2x 10y is equal to x cube. So here you have to assume 10y is equal to something new. So putting 10y is equal to u, that will give us x square y dy by dx is equal to du by dx. And therefore equation 1 reduces to du by dx plus 2x into u is equal to x cube. So px is equal to 2x, qx is equal to x cube, and if will be e raised to integration p dx. That will be e raised to 2x dx. That is e raised to x square. So your general solution will be u into if is equal to integration q into if dx plus c. So u into e raised to x square is equal to integration x cube into e raised to x square dx plus c. Now this function is not directly integrable. So we are going to put x square is equal to t, and that will give 2x dx is equal to dt. So you have x dx is equal to dt upon 2. Then that will give u into e raised to t is equal to integration t e raised to t dt by 2. Here we are separating x square into x. So x square is t and x dx is dt by 2. Here we are applying u into v. So t as it is, integration of e raised to t will be e raised to t minus derivative of t is 1. Again integration of e raised to t is e raised to t. E raised to t common out, and that will give you 10y into e raised to x square is equal to e raised to x square by 2 into x square minus 1 plus c. So this is the method of Bernoulli. Basically it is reducible to linear.